Well, this is the pack that they give you to pack up the Chameleon portable loop in. It's a nice canvas bag. It's got a carrying strap back here. That's the operating manual that comes with it. It's fairly complete. Talks about the limits of the loop. Accessories gives you sort of a quick description of how to put it together, some information about HF propagation, description of the parts of the antenna, diagrams for assembly with the included hardware. And what is that included hardware? Well, it all fits in the bag, sort of. The end of the stands stick out of the corner. Diagonally, it just barely sits in there. Talk to Chameleon, they say, yep, that's the way it goes. The bag is just so big. So, in the bag, we have the tuning box, weatherproof enclosure. They got a little screw here, screwed shut. It does have these clamps, so it could be easily opened up. I'm going to open it up and I'll show you a picture of the inside. The tuning capacitor shaft comes out of the bottom here, and that is not sealed. There's a little gap around it, but that's okay. That would be on the bottom of the box, and you'd actually want some air exchange with the inside of the box, because you definitely would not want condensation and moisture building up inside there. So it's a pretty close fit on that shaft. There's just the slightest bit of a gap around the shaft, which is probably enough for a little bit of air exchange. I don't know. If you're in a humid environment, going to be outside a lot, maybe you'd want to drill a tiny hole down in one of the corners here, just to give a bleed hole for moisture to escape. But the box is pretty well built. The hardware is installed on the back to clamp it to the mast, and we'll show all that when I put it together. We have the coupling loop, which is very well built. It's aluminum, but that's fine. The coupling loop resistance is nowhere near as critical as it is on the outer loop. It's put together pretty well. I like the design of that. And this is a threaded hole here for mounting it on top of the mast. We have a length of feed coax with ferrite core common mode choke already installed on the coax. Keep RF from coming back to you. The coax for the loop itself, nice, heavy, and stiff. One thing that they didn't do, that I did, and you can't see it in this image, but I measured to find the exact center of the coax, and I put a little electrical tape on here. So when I'm putting the loop together, I know exactly where the center is and where it needs to be right at the top of the coupling loop. That'll make it a little quicker and easier to get it symmetrical when I put it together. So Chameleon, you might want to think about doing that. Maybe in the very center of this coax, put a little band of colored tape or something to mark the center. That would just aid in setting it up and shave maybe a minute off of the setup time, because you won't have to find the center. All right, what else do we have in here? This is the mast. It has 3 telescoping sections, so you can adjust it for height so that the loop, this is the clamp where you put the tuning box on, so you can adjust this for height to get the loop somewhat roundish. The more symmetrical it is, the better. It does have a hand grip here, so you could probably use it pedestrian mobile if you want to carry that beast around with you. You could, carry this as you're walking along, I suppose. Then there's the tripod. And mine has a dent. It got dropped somewhere. Wasn't me. It came that way, dented. So, yeah, maybe their QA inspectors on the line need to pay better attention. It's not going to affect it. It's only very, very, very slight bend in that leg, so it's not really going to affect its operation any. But I did notice that there's a dent there. The way this works, you loosen this clamp up, and then this does like that to become a tripod. And that's the base of your loop. Ugh. Hopefully I'm not getting too out of focus moving this to and from the camera. Another break here, and then a telescoping section. So you can raise it up off the ground. Boy, that's I don't know if you can see that. See that bounce? There's a pretty tight seal there. That's air pressure in the tube. So it's sealed at the bottom. That's that's actually air pressure. I can feel it like a brake. Anyway, so that can be extended then to lift the loop up off the ground a ways. So yeah, nice tripod. Yeah, it's okay. It doesn't spread out very wide. If you're in a breezy environment, you'd probably want to put something on the legs to lock it all down. So these are the components for the portable magnetic loop. Coax, coupling loop, and tuning box. So yeah, I'm going to put it together. I'm going to be taking it outside with the FT817 and doing some on-air testing. Going to do some whisper beaconing and all that. But today and tomorrow, we're going to have 20 to 30 mile an hour winds here. So I'll put it together in here to show you how the assembly works and what it looks like together. And we might do some whisper broadcasts from inside the RV just for the heck of it. I'll probably also hook up the mini VNA and do a sweep to show you how narrow its bandwidth is. I'm sure my exposure's all screwed up. I can't find a good combination of lighting and not a lot of room in here to work, but we're going to do what we can. So the first thing I'm going to do is I'm going to expand the tripod. And then we're going to extend the end of it a ways. I'll set that down there. And then we'll get the loop support shaft, and that threads onto the top of the tripod. Okay. Now, the loop box goes on here. There we go. All right. Next, I'll put on the coupling loop, which threads on get that kind of parallel or perpendicular, however you want to describe it, to the control box. And then the loop. Now, there's these two little Velcro straps, which are handy, that hold the cable together, and you're going to use the same straps to strap the loop to the top of the coupling loop. So we'll open that up. Now here's where my piece of tape is handy. I've put a little piece of tape on here so I can feel right where the center of that is. So I'm going to just take that, and I'm going to kind of uncoil the coax a little bit, just sort of take some of the spring out of it. And I'll put that center right there on the top, and then we'll take the Velcro straps and we'll just strap it down onto the loop. This is a little tricky, getting it tight. I kind of found that if I pinch the strap with my thumb and then use my fingers to pull the coax down, I can pull this strap through there, and there, it's on. Okay, now I need to extend the shaft. And I'll do it about that far, and we'll see how these connectors line up. And you want to get these nice and snug, you know, and wiggle them and make sure that those PL259 connectors are seated on those SO239s, because that electrical contact is important. What kills a magnetic loop is DC resistance in the outer conductor. So you want to make sure that you got these nice and tight. I mean, you wouldn't want to tighten them down with pliers or anything because then you could damage them. But you definitely don't want them wiggling around on those connectors. You want them good and tight. And you also want to look at the rotation of that coax so that the plane of the loop stays in line with the plane of the coupling loop. So that's probably good enough to operate. What I like to do then is I'll just sort of form the shape of the loop a little bit, try to get it as symmetrical as possible, because that's, going to make a big difference on tuning. So that's pretty much it. It is now set up. Let me move the camera up. It's pretty much set up now to operate. The only thing left to do is to hook up the feed coax. Now I might dig up another little Velcro strap, because what I want to do is I want to kind of strap this back here. I want to keep it in the center. There's a null on a magnetic loop going off perpendicular to the loop and in the center of it. So if I keep the feed line along with that center shaft, I should also reduce the amount of RF that can come back on the coax. So we'll hook that up. And yeah, see there? Okay. That would pretty much be it. It should be ready to operate at this point, ready to tune and get on the air with. Pardon the funky background. That's an old beach towel that I used to fill the gap between my blackout curtain and the roof and retain as more heat inside the coach here. On the coupling loop, the amount of area where this is in the proximity of the coupling loop is critical. I played around with widening these out, crimping it down. The SWR was almost 2.5 to 1. I started backing off until I found just the right measurement. Narrower than this, and it started to go back up. So you'll want to fiddle around with the center point on your loop and with this gap for how far out you've strapped it down with a good SWR meter, or if you have something like the BNA, that's the best way to really see what's going on. And find the sweet spot. And once you found the sweet spot, I am going to mark the cable and the coupling loop where I've got my straps and where the center point is, so that when I set it up in the field, I'll know precisely where I got the best SWR. And I've got it down below 1.5 to 1 with these settings. So that's a point, or that's a thing you can do to save yourself some time in the field. Here's a scan with the mini VNA. I was working at tuning the loop for doing some whisper beaconing, and boy, it is touchy. They are all touchy. The knob on the tuning block is a vernier drive, but still just barely touching it. I mean, even to the point where I didn't think that I turned it at all. I just put a little pressure on it. I didn't think it moved, but I saw the SWR dip move from 14.07 to where I want it to be. And I didn't even think I moved the knob. That's how touchy it is. And you can see how narrow it is. The SWR, we're below 1.5 to 1 at that frequency, which is right about where the whisper transmission is going to be, I think. Right in there. But if you go just a little tiny bit down, you're over 2 to 1. You go down to 14.05 from 14.09, and you're over 3 to 1. So that's how touchy these things are and how narrow they are. You'd really need some kind of a tuning aid to do it in the field. You could get it close enough where the radio's happy just listening to the static, and the SWR meter might only be tickling on the Yaesu. But you really need to fine-tune it if you want to get the most efficiency out of it, because the difference with just a few kilohertz or a few hertz there, it's going to be a big difference in radiation efficiency too. You get over 3 to 1 SWR, and you're just not going to be generating as strong a field. So, yeah, when I get it outside and get set up to transmit and play with it on air, I'll be using my field strength meter to fine-tune it.
Romeo Tango Victor. If I missed anyone, please let me know. I don't want to do that, but I think I copied all stations. Any other check-ins? Come now with your call sign.
Kilo Bravo Niner Romeo Lima Whiskey Portable 6 QRP.
Okay, I heard CZI, Jay, good morning. TTY, George, good morning. And Jim, good morning. Echo Oscar Whiskey. And someone said portable station, so the portable station, come back with your call, please.
This is Kilo Bravo Niner Romeo Lima Whiskey Portable 6 QRP.
Okay, if you're running QRP, please, if you have any power, I would use it. Conditions are very poor right now. But I heard someone say portable station. We'll stand by. Give us your call sign, please, and take a turn. If we can hear you, we'll do so. Go right ahead.
Kilo Bravo Niner Romeo Lima Whiskey. Kilo Bravo Niner Romeo Lima Whiskey Portable 6. Portable 6. Kevin. Kevin is the name. Kevin. I'm in the desert north of Yuma, Arizona. North of Yuma, Arizona, running 5 watts. 5 watts. Over.
Okay, good morning. Kilo Bravo 9 or something. I missed the last letter. I understand you're in Yuma, Arizona, running 5 watts. So good morning to you. Conditions, I probably don't have to tell you this, are very poor right now. So I copied you a little bit. My call sign is Kilo Echo 7, Romeo Tango Victor. So thank you. What's the last letter of your call, please? Over.
Romeo Lima Whiskey. Romeo Lima Whiskey. Romeo Lima Whiskey. Over.
Okay, Kilo Bravo 9, Romeo Lima Whiskey. Good morning. This is the early bird net, and we meet every morning, 7 days a week at 7:30. So congratulations, you got through on 5 watts, and thanks. Stand by, we'll call you again.
Alright, there's wind noise, so hopefully you can hear me. I don't have a windsock for the GoPro, and the wind just kicked up. So I've moved frequency, and I'm going to tune the loop. Now, the easy way to get close enough to probably operate is just to listen to the noise and rotate the dial until you hear a peak. And let me show you how far I'm turning that. Alright, listen to the noise. So you could hear how sensitive it is. Just the slightest turn of that knob and I'm past the peak. Now what I do to fine tune it is I'll take the radio down to low power, hop into CW mode, and I've got my field strength meter here. So I can see an indication of RF from the loop. And I'll just tweak the dial for a peak on the meter. Now I am tuned right to my frequency. That's the strongest field I can get out of it, so that's where I should be, and I'm ready to operate. I can switch to high power, and the Yaesu is showing no SWR. Well, I guess the last thing to do is to take a look inside the magic box. Now they use a nice weatherproof enclosure, and it's got these latches, but it's also screwed shut with a teeny tiny hex head screw. So I'm going to void my warranty so you guys can see what's inside of here. I know Og has already opened one up, but we're going to take another look ourselves. Okay. Oh no, it's just a neoprene seal, no big deal. And there she is. Now, okay, I see what they did. They wired it correctly. A vernier drive here. So, let's see. 1, 2, 3. We're almost there. Oh, 3. Okay, so it's a 6-to-1 turn ratio, because 3 turns I went 180 degrees or halfway. The cap looks really shiny, like there's grease or something on it, but I don't think so. Okay, what they did here is, you can see the wire. One side of the loop is wired to the bottom plates here. The other side of the loop is wired to the bottom plates here. So there's no actual connection to the center shaft. The center shaft is the connection between these outer sets of rotating plates, right? Normally on a variable capacitor, the center shaft makes electrical connection to the shell, and through the bearings or through a wiper. This doesn't have a wiper, it's just got bearings at each end. And so one end of your capacitor connection will be to the shell, the metal frame, and the other end will be to these bottom plates. But what they did is they wired to one set of bottom plates and the other set of bottom plates. So what this is it's like 2 capacitors in series. Let's look at it on a schematic. So what we've got is we've got 2 capacitors in series, essentially. And that center shaft is this interconnection between the 2 caps. And by doing that, you do 2 things. One, you double the voltage handling capacity. If you remember from basic electronics, or if you didn't know this, if you put 2 capacitors in series, you halve their capacitance. You cut their capacitance in half, but you double their voltage rating. If you put 2 capacitors in parallel, you double their capacitance, but you cut their voltage rating in half. And the reason for that has to do with plate area and gap. By putting them in series, you're adding the gap of each set of plates together for your total gap. So it takes more voltage to jump across that total gap. If you put the capacitors in parallel, you're increasing the surface area between the plates, essentially. So you're increasing the area over which a gap, an arc could jump, and you're cutting the voltage in half. So by putting these 2 banks of capacitors in series like that, they have doubled the voltage handling capacity, which is important in a magnetic loop because the RF voltages at this point are quite high. And they have also eliminated the potential for resistance, electrical resistance through the bearings, which would have been the contact point to these center plates, right? And electrical resistance is what kills the loop. It also is a point of noise, a possible point of noise. As this is rotating, the electrical connection between this outer shell and those bearings and the center shaft can get noisy. So by eliminating electrically connecting to this and letting those just act like a series capacitor, yeah, that's the smart way to do it. So it's pretty clean in there. And we got a nice neoprene gasket here. I think it's neoprene. Yeah, it's spongy. So a nice weatherproof enclosure. And there is a slight gap around the shaft where it goes through the plastic. So you've got air exchange, which should cut down on condensation. We'll have a look inside of here again in a future video. Whenever I get the power compensator from Chameleon, we will be testing the power handling capacity of this and taking it up to where we get a small arc and seeing how that changes as we go, as we put in the power compensator. But that'll be a future video. So what do I think about the Chameleon Portable Loop 2.0? I like it. The construction's great. I wouldn't expect less from Chameleon. My experience with their hardware so far has been that their construction is excellent. They use high-quality hardware. The box, the capacitor in, nice weatherproof box. Well, not weatherproof, weather-resistant. Yeah, it's rugged. It's well put together. The pros, well, it's basically a magnetic loop. From my experience with the ones that I've built and other loops that I've seen, you know, its performance is what you'd expect from a magnetic loop. Sometimes surprising, often good. As you saw, even though the bands are in pretty bad shape today, I did check into a net with it using 5 watts on single sideband from the Yaesu. So yeah, you get out. Very portable. It fits in that little bag. That, I think, is its biggest selling point. It's a very good portable loop. Easy to tote around. If you were going to do a Summits on the Air or Parks on the Air activation, where you're going to sit on one frequency and not have to tune it often, it would be ideal. Very easy to pack up and set up, and you'd be on the air pretty quick. Yeah, it'd be great for that. Tuning, it's not that bad. I thought that it would take a lot more fiddling after scanning it with the mini VNA and seeing how narrow it was. I thought that for general operation it would just take a lot more fiddling than it did ultimately. You could tune it by ear and then tweak it using the SWR meter on your radio and probably be fine. I like to really get it down, and using my field strength meter for fine tuning it lets me get it right to the exact resonant point for where I'm at quickly. And that's my favorite trick with magnetic loops. Field strength meter, measure the radiated field, and when that peaks, you know, you're tweaked right there, you're fine-tuned. And it's not really all that fiddly. I figured it would be super, super touchy, but it's really not. The vernier drive is very tight. There's no lash or slop to it. Very quick and easy to tune. So, and no hand capacitance. That's the other thing I didn't mention about that arrangement, using the center shaft as a series connection between the two capacitor gangs. You reduce the effect of hand capacitance when you bring your hand in. And I didn't see any. I was watching the meter when I was tuning, and I would experimentally take my hand away and bring it back up to the knob, and I didn't see any variation at all. There probably was maybe a few hertz variation, but you know, definitely nothing that affected the SWR or the power level. So actually pretty easy to tune in that arrangement. Yeah, it's a good magnetic loop. Cons? Well, if you're really persnickety about it, the efficiency is not going to be what it would be with a loop made out of copper pipe, where all the joints are soldered or welded, and the copper is a higher or lower resistance conductor, obviously, than the braid in the coax. So efficiency is not going to be as perfect as you could make a magnetic loop, but it's definitely good. Good sensitivity. I was able to get out. I've had a couple of QSOs on it. I will be using it in the future. There's another pro. That portability and ease of setting it up, it's actually easier for me to set that up than it is for my big loop, where I put the stake in the ground and set the loop up, hook up the tuning box and all that. But here's a con. You have to be next to the loop to reach over and tune it. So it's got to be close to you. Now, if you're not running much power, which generally you're not with a magnetic loop, not a problem. But if you want the loop to be more remote, away from your radio, there's no remote tuning. So that's, I guess, if you really want to look for something to say negative about it, that would be as close as I could come. But I don't think that's a big deal. Not for what it's built for. It's built for portable operations. And for portable operations, I think it's an excellent magnetic loop. I hope you found that helpful or informative, and we'll see you in the next video. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.